So now that we've looked at the Bohr model to understand what valence electrons are and where they're located, and then finding that shortcut using the periodic table to find the valence electrons, we will now look at the electron dot diagrams. So here is a step-by-step process of how to draw the electron dot diagram. Ultimately, you are trying to show the number of valence electrons that each element has using this diagram, and we'll see in the future why that's really helpful. First, you're going to write down the symbol, of course. So if you're looking at sodium, it's going to be Na. Then you will find the number of valence electrons. The number of dots you're going to draw equals the number of valence electrons. You start with one dot per side of that symbol, and you may double up if you need to, but no side should have more than 3 dots. So for example, all of these are incorrect. If we're looking at how to draw an electron dot diagram for carbon, the dots do not go all on one side or on a slant or fill up these 2 spots without filling up the top and bottom. Imagine you are trying to contain the symbol, the element symbol, as if it was a wild animal and you need to keep it in a cage. If we're looking at drawing this dot diagram for carbon, we know that carbon's total electrons is 6, right? The atomic number is 6, so we have 6 electrons. The number of valence electrons I've already figured out for you by using the group number 14 and looking at that chart in the previous slides. So here is what that dot diagram should look like. All 4 dots are going to be taking up those spots surrounding carbon. Let's do another example. So we're going to draw the Lewis dot or the electron dot structure for sodium, Na. So step 1 would be locating Na on the periodic table, looking at how many electrons it has. So that's what we'll do. So I've pulled this up from a periodic table. You can see the atomic number says 11. So my electrons would be 11. Oh boy, 11 electrons. All right, now what? Step 2, I'm going to look at this periodic table here, and I'm going to find Na right here. And so I see that it is in group 1. We'll use red. Group 1, because it's right here. So if it's in group 1, that means I have 1 valence electron. Now I can look at this chart and kind of understand, well, how does it have 1 valence electrons? We just saw that it had 11 total electrons. So there's really only 1 electron that matters in terms of how it bonds with their atoms. Well, let's take a look. If it has 11 total, we know that we fill up these first 2. They're the closest parking spots to, our mall or our target here. And then we count the rest. So 1, 2, 3, 4, 5, 6. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So because I just have 1 electron in the outermost ring, that means I have 1 valence electron, right? This is the long way. This is the shortcut. So I have 1 valence electron. That means I just have to draw 1 dot next to Na. So if I'm just trying to do the Lewis dot structure, the electron dot structure for Na, this is what it would look like. Na 1 dot. Now let's do another one, chlorine. So we'll do the same process. I'm going to look at the periodic table and try to find chlorine, and here we are, right here. And so it is in group 17. It's a halogen. So if it is in group 17, that means by doing the shortcut here, I have 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. Now, if you thought, well, does it matter if I start on this side or this side or this side? No, it doesn't matter. So if you were to actually have, well, gosh, let's just have it drawn like this, it doesn't really matter. As long as you have your 7 valence electrons and they are no more than 2 per side of this element symbol, you are right on track. Now, the thing that is important to remember for the future, when you have elements that are bonding together, remember we have covalent and ionic bonds, you will need to somehow show how these elements bond together using a Lewis dot structure. And that's what we'll be learning next time.